Yeah, where you?
We're moving on to chapter 2. So we study how to find the derivative that is really defined as the slope of the tangent line. So we actually, even though we involve the limit calculation, but essentially we're still dealing with the derivative. We're dealing with the slope. And slope is geometric term. It has its geometric meaning. So, so let's say you get 4x plus 90. What is the slope? You can also use the limit definition to calculate the derivative, but you should get the same answer as you would find as the slope of the line, slope of the function. After a while, we normally remember derivative derived from the original function, and we kind of forget that derivative is actually the slope of the tangent line. But the geometric meaning of it actually is very important for us to understand what is the derivative exactly, and how would knowing derivative help? Because really, derivative is the direction of the function, and knowing which direction are we going, up or down, fast or slow. So if you are going through the calculation using the limit definition, slope is really derivative is defined as a limit of f of x plus h minus f x over h. H is also the value that you get taking the x value subtraction. That is x plus h minus x, and that is h. The denominator really is subtraction of the two x values, numerator is subtraction of the two y values. You make h go to 0, that is making these 2 points getting closer and closer. That's really the definition of derivative function. So for this function, if we write it out, I mean, limit is what all we deal with in chapter 1, and it's really important to understand sometimes the limit question is given by symbolic notation. And one of the things we have to do is being able to write out the symbol. Okay, for example, by definition, f of x is 4x minus 4x plus 90, so it's minus 4x plus 90. That part can be directly taken from the definition of f of x. It's the first part that needs us to be focus on.
Actually remember the formula.
Right. So this is the definition of formula, but we gotta write out the formula for each f of x. So f of x plus h is yes.
Another thing you should do is that you should place it like where the x is located, like in the equation, like insert it for x plus h.
Right. Yes. So we should insert x plus h where the x is. So we substitute x plus h here, substitute x plus h for right after the 4. So become 4 times x plus h plus 90. That's the first part of it. So from here to here, it's normally a big jump because many students tend to get overwhelmed by looking at the notation. What does it mean? How do I exactly write it out? So one of the things is carefully switch from symbolic notation. Those f are function names. That's a symbol that is being inserted into the limit calculation. So sometimes writing out the f part is an issue, and we kind of get overwhelmed and forget how to do it. So once you write copy over f of x and copy over f x plus h, and then we should start looking at the subtraction. If we remove the parentheses from both of these two terms, we distribute the 4. That's 4x plus 4h plus 90. And we distribute the negative sign. It's negative 4x, negative 90. Distribute the sign. And that removes all the parentheses. And then we start looking at combining terms.
Yeah, it's basically the 4x, and the 90s both contradict, or basically both cancel each other out because one's positive and one's negative.
Right. The positive term and the negative term cancel each other out. And then we can see the numerator gets simplified a lot in this step. So if we're careful, we should be able to have your answer. Was it? Yeah. So, I do All right, so we cancel a couple of terms, 4x minus 4x, 90 minus 90. The only thing that we have left is 4h. So we get 4h over h, and h approaches 0. All right, if you make it h approaches 0, this is really 0 divided by 2. It's 4 times 0 is 0, h equals 0, h approaches 0. So that's approaching 0 over 0 term. But we know that the numerator and denominator both have h is a common factor. So we should be able to simplify it before we calculate the limit. So we always simplify. Then the h cancel, we have a 4. So now 4 is a number. A number will not be changed. It's a constant number. So when h approaches 0, the limit is still 4 because we no longer have a related variable in the expression. So the final answer to the question, the derivative actually equal to 4. Let's summarize. If you have f of x equal to 4x plus 90, and then you should have the derivative, which is derived from the original function, the derivative actually equal to 4. Another way of looking at it is 4x plus 90 is the equation of line, the function of line. The line has a slope, and the slope is that number coefficient of x is the slope. And therefore, understandable if you try to find the derivative, which is the slope of the line, which will be 4. So just grab the slope, and that's already the derivative. That also gives us another thing. If you do not have a variable term, if f of x just equal to 90, then guess what's the derivative? It's 0. Okay, that basically means that the slope of the line. This is a horizontal line at 90. Because it's horizontal, there's no increasing, there's no decreasing, there's basically no change. Therefore, the derivative would be 0. Derivative 0 means that the whole function has made no change. All right, when the derivative is 4, we know the line is going up, it's increasing. So derivative positive indicated increasing line or increasing direction. Derivative negative means decreasing, the line goes this direction. But when the derivative goes to 0, that means there's no increasing, there's no decreasing. So derivative really give us the direction of going this way, or this way. So increasing, decreasing, or no change. All right, so then that gives us some idea, at least for equation of a line that we already know how to find the derivative. All you have to do is grab the slope, consider what's the slope, and that slope value should be the derivative value. I still see a few wrong answers. I wonder whether accidents or did you submit the one earlier? Feel free to change it. Anyone else accidentally submitted wrong one? Tyler? I think you submitted wrong. It's 4.
Oh, yeah.
Anyone else? Someone try to look into the system. Ernest still. I just want to make sure I answer the thing. This is also double as our attendance check, so I'm trying to get everybody answer the right one. So I also want to make sure that you did know what was the right answer. That's why I try to get people to switch. Any homework question? We started with 2.1. Yeah.
I'm having some trouble with number 3.
Number 3. I hope you didn't finish chapter 1 homework because I opened it before the test. Just try to make everybody finish the homework as a preparation for the test. Number 3. Bring this one. Yes. Okay. All right, so this kind of question, what we're gonna do is try to find the derivative function. And once you have the outcome of x, you can plug in 4, plug in 3, plug in 0, whatever derivative you wish to find, and we'll be able to apply the formula. So let's try this. So we're gonna write down the function first, and then we write down the calculation of the derivative. So this is the function. Okay. Let's first find the derivative function. Then we're gonna plug a number to the derivative in order to calculate the slope. So this is equal to write down the definition of f of x plus h minus f of x. Those are subtraction of y value divided by h. That is subtraction between the two x value, h approach 0. This is the definition. So you can use this definition to find the derivative of any function. So I'm going to plug in x plus h into the x plus h. So it's 1 over x plus h plus 1. That's the first one. And then f of x is the same as that definition. It's 1 over x plus 1. That's after we write out the f symbol. The f of x plus h, those are names of the value, and you, according to the definition of f of x, you rewrite them, and now you actually have something to calculate. So a derivative function is a function, so the answer to the derivative calculation is a formula with x in there. So we're calculating something that has x. That's why there's x in there. So then we're gonna try to think about how do we calculate this exactly? This is a subtraction of fraction. If you want to subtract fraction, you have to have common factor, right? We can't subtract it right now. I think I mentioned this last time. You can have 1/3 minus 1/5. We can't really subtract them immediately. What we're gonna do is we wish to have the same number in the denominator, then we can subtract the numerator part of it. So common denominator between 3 and 5 has to be 15. So we wish to get both of them have 15 as a denominator. But if you want to get 3 to switch to 15, you have to multiply 5. That becomes a 5 here. Right? If you wish to 1/5 become a fraction that equal to it, then 5 has to multiply 3. So the 1 has to multiply 3. So that's why we get 3 from here. 1/5, 3/15, they're the same fraction, except we write it into different format. So fraction is that kind of thing, numerator, denominator multiply the same number, then they will be the same fraction. So this subtraction is the same as this subtraction, except this subtraction not have the same denominator. We subtract the numerator, the answer is 2/15. So that's how we subtract number when they do not have the same denominator. We force them to have the same denominator. And we do the same here, that this denominator and that denominator are not the same, just that extra h. So we're trying to make sure we construct. Yes.
So basically, like we're multiplying like the denominator x plus 1 with x plus h plus 1.
Mm-hmm. Yeah.
Right.
Yes. So that will be the choice of the common denominator. We make them to be the same. So this is going to be a bigger fraction, bigger denominator. So the denominator we choose to be x plus h plus 1, and then x plus 1. That's what we're using. And here is x plus h plus 1, and then x plus 1. We're trying to make sure that this denominator has both of these two things. All right, then you want to make sure the denominator has no change. The numerator part of it is the part we got to be careful because we want to make sure that we didn't change anything. We changed the format, change the look of it, but we want to make sure they're the same thing. So from here to here, we multiply the denominator by x plus 1. So we have to multiply x plus 1 in the numerator. X plus 1. All right, we do this because we did multiply extra factor. We multiplied this. We have to multiply the same thing in order to make sure this equal to this. All right, I have students, they move from here to here and they cancel it. So that was went backward. So try to remember that we want to keep it this way because only when they have the same denominator we can do subtraction. All right, we do the same over here. The x plus 1 was there, but now x plus 1 is still here. But we have this extra x plus h plus 1, and therefore we got to have the x plus h plus 1 in the numerator, just so that it will be consistently equal to the same thing. So this is really the step that is harder for some people because we are not very familiar with the calculation of fractions. If you want to subtract fraction, these two fractions have to have the same. Now they do have the same denominator, therefore we are able to subtract. Any question? Yes?
Can you go over problem number 1?
Okay, sure. All right, so over here we finish getting them to be the same denominator. Let me try to remember number 1. So now we can finish this. Here, this limit is, now we subtract the numerator, that is x plus h. All right, the denominator is x plus h plus 1 times x plus 1. Numerator is x plus 1 minus x minus h minus 1. So it's a subtraction of all of them. That's why we have to subtract every one. And then they're still over h. H equals to 0. Now, this subtraction, x minus x, 1 minus 1, is negative h over x plus h plus 1, and then x plus 1. This is a complex fraction because you have a fraction in the fraction, this is over h. Now this h and that h, one in the denominator, when numerator they cancel. So that's common factor. After you cancel, there's no more h in the numerator. That h cancel this h, you have -1 over x plus h plus 1, and then x plus 1. So after we've done that, we can now let h approach 0. This h approaches 0, that's 0, so that's x plus 1. X plus 1 times x plus 1 is x plus 1 squared, -1 x plus 1 squared. So that's the derivative. Going back to try to match the original. Original function is a fraction, then the derivative is another fraction, x plus 1 squared. So that's the derivative of the function. As we look at more and more example of derivative calculation, we start seeing patterns. Fraction and a derivative is a fraction. A degree 1 polynomial, the derivative is degree 0 polynomial. You can see some pattern and rules. All right, the rest is plugging the number. For example, the first question we're going to calculate f prime of -4. So since f prime equal to -1 over x plus 1 squared, so f prime of -4 equal to -1 over -4 plus 1 squared. -4 plus 1 is -3, -3 squared is 9, so it's -1 over 9. Okay, so we do the same for all the other examples.
Oh, so we essentially just, all right. I'm starting to piece the puzzle pieces now.
Yeah, once we figure out the function, we plug in these values. And so it's very important to know the function and what's left is just plug in numbers. This is So all you have to do is plug in the number into your derivative function. Does that answer the question?
Yeah, kind of.
Do you have the same or do you have a slightly different number? Is your number same as this one? I have 1 over x plus 1. Do you have the same? That's different.
Okay, so something never mind. I never mind. I found out the answer to my own question.
Okay. This question is because the function can be simplified. So this is not a limit calculation. This is just a step in the limit calculation. It says we just try to simplify this. So it's a simplification question. We focus on f of 7 plus h minus f of 7 over h. Because type it out. If I write on the board, all right, so we're trying to calculate this division. Of 7 plus h of 7. That's the numerator. Denominator is h. So that's really the question here. We're trying to figure out what is this. We want to simplify it. Hopefully the numerator and denominator have common factor. We can cancel the h. So we're going to write it out. Since this one has 1, 2, 3, the definition of fx has 3 terms, then both of these two can be long. So in order to save spaces and make it more organized, we can calculate by themselves and then plug it into. So for example, we can calculate f of 7 by itself. F of 7, because f of x is 9 times x squared minus 5x plus 6. So we're going to plug in 7, so it's 9 times 7 squared minus 5 times 7 plus 6. All right, that calculation 7 has to be squared first, so it's 49 times 9. So 9 times 49 minus 35 plus 6. We can pop this into a calculator just to save time. So it's 412. So this is now, this part is minus 412. Make sure this part is minus 412. Because I know F7 is a function value when x equals 7, that can be quickly calculated to get that number down. So I'm trying to avoid having this one at the really lengthy calculation. So I get that lengthy calculation down by itself. So do individual calculation and then construct the fraction after it's done. Then the other one is you will calculate out of 7 plus h. But I didn't do the like that on the board because those are fractions. If you plug in x or x plus h, they're not that long, so they're kind of short. So I place them together in the limit calculation. But this, I think, since there are 3 terms in the alphabetics definition, this calculation is long, and this calculation is also long. It's better to get it down and then construct it into fraction. This is going to be 9 times 7 plus h squared minus 5 times 5x. It's really the x replacing x replaced by x plus h. 9 times x plus h squared minus 5 times x plus h. Then plus 6. That's x plus h. You should do 7 plus h. X is 7 here. So that's subtraction f of 7 plus h. 7 plus h replacing the x. So 7 plus h replace x in the original calculation. You got this, and then start calculating exactly 9 times. So this is a perfect square. If you remember, when you find a square, a binomial, you follow a formula, or you can just derive it yourself. That is x plus square. Here. Square. So a plus b squared is a plus b times a plus b. If you follow this, it's going to be a squared plus ba plus ab squared. You treat this as a formula because every time a plus b squared is equal to a squared plus 2ab plus b squared. This is always will be whenever you have 2 terms squared, you end up having 3 terms. So over here, 7 plus h squared, you square the 7, which is 49. And then plus you multiply the 2, that's the a times b. Now you have 7 times h, 7h. But you have to double that, so that makes it 14h. If you want, you can also do it by yourself. You go 7 plus h times 7 plus h, and you follow it. You get the same thing. But I always felt like knowing the formula might be faster than having to do the calculations. So this is what we have after we expand the square term. And we have -5 distributed, so -5 times 7 is -75. And then -5 times h is -5h. Any questions? Right, and this is the reason I put it by itself, because if you have this over here, you have to carry over everything together, so the calculation can be lengthy. So it's better that we simplify it first. All right, moving on from here, we have this is equal to 9 times 49 plus 9 times 14 h plus 9h squared, and then minus 5 minus 5h. This is expanding it without parentheses. See? All right, and then we realize 9 times 49 minus 35 plus 36. 9 times 49 minus 35 plus, that's 412. So the number term equals 412. And the degree 1 term, there's a degree 1 term here, there's a degree 1 term there. So that is really 14h minus 5h. We combine them. Then we have the square term is 9h squared. So this is after we combine the number, this number, that number, and that number, which was already combined when we're calculating this one. I know that it's 412. And everything else, I copied it over because I think this can be simplified to copy it. So at least that's a shorter. So this is the unexpanded, like concise form, and that this is when you expand it and then combine like terms. Now we can use it over here. Write it over. Go back to the main calculation. All right, calculating these two just to ease the complexity, just to make sure when we do this, it won't be overly long. Sometimes when the expression, when the representation is long and complicated, it make it hard for us to identify the pattern or combine like terms. So I try to do it ahead of time, and then what we have is just over, and then we're supposed to grab that part, and that's supposed to replace f of 7 plus h. So this is equal to f of 7 plus h. It's supposed to minus 412. Subdivision. And this is divided by h. So this is expanding it. We were supposed to calculate this big fraction. Denominator is pretty simple, but numerator is long. So we try to write out what is f of 7 plus h and what is f of 7. F of 7 is 412, but f of 7 plus h is this. But then we realize 4112 is part of it. So that can be simplified. Cancel that part. This is equal to. Your version, you should see similar situation. The numerical term are canceled or combined, and all we have left is a number term. If you can, we should multiply 9 with 14. 9 times 14 is what? 100. 126? 26. Okay. So we then end up having 126h minus 5h plus 9h squared. But at least there's no more number. We want to divide it by h, and h is a common factor. So we can divide h from each term. So 126 divided by h, 5h divided by h, 9h. They all have to be divided by h. Another way to do this is factor the h. H is a common factor. To bring the h out, we have this. So it's 126 minus 5 plus 9h, and you bring the h outside. H outside. H. At least now you realize that h is a common factor. The numerator have a factor h, and the denominator have a factor h. You cancel them. All right. So the final answer is being 126 minus 5. We should combine them a long time ago. The 126 should minus 5 over here, but I didn't do it. But now we should. Well, you can do it early or late, but 126 minus 5 is 121. So the final answer is 121 plus 9. And we can answer the question. After you simplify, you should get something like a times h plus b. Now the h, a is the one that multiplying the h. We have 9 multiply h. So the one that multiply h is a, and a in this case is supposed to be the 9. 9. And this is the, that's really the answer to the question. Does that answer your question? Any question? Does that answer your question? Try it on your version of it. It looks lengthy, but the overall idea is we try to simplify the calculation in order to make the final version of it not as complicated. Otherwise, this is wrong, this is wrong. Sometimes it gets overwhelmingly messy. That's why I try to get the individual calculation done, and then combining them together wouldn't be an issue. It's still kind of long, but it's easier to track the term, like 4 terms here, 1 term there. For the 5 after subtraction, there's only 3 terms left, so it won't be as messy. It's sometimes writing it tidy, sometimes organizing in a shorter way. It helps, even though it's a small things. Conceptually, we should have this thing over here, and then this is over here. If you did do it that way, you would have having, see that's 1, 2, 3, 3 terms. 1, 2, 3, 3 terms. So you're gonna have 3 minus 3, 6 terms. And then some part of it has to be expanded. This one after you expand it, it's even longer. So it can get really messy. At least the presentation will be hard to manage. Slightly precisely. The solution is really not unique. If you are the one that kind of tend to write things really neat, there's no problem. You can just start like everything from the beginning. But I'm really the kind of people that tend to write things to the point that the writing is all over the page, and it's really hard to identify where was the solution, which one was. So I try to manage myself, like force myself to organize things. There's still at times there still looks messy, but at least it makes it slightly easier to manage. All right, so answer to the question is 9 and 121. All right, we're all human beings. I think many people have this weakness, and for me, my weakness is I'm not careful. I tend to, whenever I'm rushed or nervous or I try to get things done in a very odd, different way. I tend to make calculation errors. So I try to change my own habit so that at least the way I do it have a less likelihood to make mistakes. I can't really 100% see I'm not making mistakes, but I try to lower the likelihood by making myself do things slowly, do things slightly differently. And that lower the likelihood of it. But try to figure out how you learn things. If you are the kind of people that tend to write large, and then you should give yourself more space as you write. If you tend to write things messy, and then you think of ways that if you write it this way, it's less messy. If you write it that way, it's more messy. Then you should choose the one that tend to make it much more easy for people to read or understand your writing. And presentation is really part of the life skill, and hoping that as we go through years of learning, we get better and better at presenting our results. Any other homework questions? Yes. Okay. So this is another function of degree 2 pronouns, and we're trying to find the derivative at -1 using the definition. So this is really involved understanding the definition. as x approach something of the function, the value of this limit is all right, so this one has a slight different way of defining the derivative. I'm guessing that's why it's difficult to write out the question. We have to change the variable to x rather than h. So let me try to compare the definition of the derivative. It says the limit as x approach something. So our definition for the derivative is this limit of, you have h approaches 0. That's our variable. But in this question, it says x approach something. If I think of it as when x approaches -1, because that's really the limiting process. That is, we're making the point getting closer and closer. So this question, we want to find, so you got a polynomial. This, all right. Want to find the derivative at, let's say, -1. So here's -1, and then you have another point right here, which supposedly would be -1 plus h. All right. So this is a 2 point. You find the slope of it, and then you make h approach 0. If h approach 0, what happens is this point gets closer and closer and closer to here. Eventually, going to find the slope of the hinge line. That's the process. So as you're making h approach 0, then we're calculating this. Well, original definition. Let me write the definition. X over h. Now, what we're calculating is f of -1. So f of prime of -1, derivative of -1. So we're calculating this f of -1 plus h minus f of -1 over h. So if you're calculating derivative of -1, you're using -1 to replace x. So that's -1, that's -1. So we're really calculating this. The scale we're using this definition, h is approaching 0. So as you make h approach to 0, you make this point getting closer and closer to -1. So if we call this one our variable, which is x, then what this point is getting closer to is this x, which you put a -1 plus h, is getting closer to -1. So if we switch the notation to x approaching -1, the definition can still work. Then instead of f of -1 plus h, we have f of x minus f of -1. We actually have this, but we're calculating a slope. A slope is subtraction of the y value divided by subtraction of the x value. So what's our x value? It's x. X is one x value, and -1 is the other x value. So we're going to subtract the two x value. This x that's in the f, this -1 that's in there, that's supposed to be the subtraction. That brings up another way to define the derivative. Many textbooks are writing the derivative not the way we write it. They have it this way: limit of x, which we can't really call it this way. Yes, another way to define the derivative: f1 of a is limit of x approach a, f of x minus f of a over x minus a. Some textbooks are using this, but they're actually equivalent. It's kind of like having x plus h for x, but having another number. You subtraction of the y value divided by subtraction. That's still the slope. So this definition of the benefit of it looks like a slope, the limit of a slope. But it has a problem is that we are not able to keep the variable, because if your variable is x, then your derivative variable cannot be x. So we have to call it f of c or f of a or something that kind of changes the variable in order to keep a variable as x. And that's why many textbooks are using this definition. So anyway, what point is, now we're doing this calculation. I don't know, this is not our official definition, but it actually helps to know there's a different way to define the derivative. To this question, we're calculating the derivative with x approaching -1 of the expression, which is supposed to be this expression. this expression, and you have to write it out. It looks like this. I hope you can compare with your version of it. If you're still confused, I can bring your version because I'm looking at my version. F of x is the original definition. It has the benefit of not have to change it. There's the f of x. That's the f of x. So we're gonna switch the notation. F of x is like x squared, 4x squared plus 3x plus 5. That's the defined f of x. And minus f of -1. Plug in -1 here. 4 minus 3 plus 5. That is 6. That's f of -1. And the denominator will be x minus -1, which is plus 1. That's what goes in the second blank. Of course, 5 minus 6 is -1. So we can just enter that fraction on my version. It looks like 4x. Let's see how much this 4x. Wonder if we can see it. 4x squared plus 3x plus 5 minus 6, so it's -1. That's the numerator. The denominator is x minus -1. So this one. So far. All right, and then we were supposed to calculate the limit of this, the value. That's really the derivative, which can be calculated using the original. You can use this one or you can use this one. Since we're already here, let's go ahead and calculate it. I'm going to calculate this limit. Let's calculate limit as approaching -1. Here you have 4x squared plus 3x minus 1. This is x plus 1. So in order to calculate this limit, you see if x approaches -1, this is 0. If this is the -1, 4 times 1 minus 3 minus, that's also 0. So this is 0 divided by 0. So I realized maybe the numerator have -1. That's 0. So we can do this consecutive division. 4, 3, -1. And we know that -1 is 0. -1, 4 multiplied 4, 1 multiplied calculate, that's 0. That's the 4x minus 1. That is x plus 1. Okay, so the numerator is now, numerator is x plus 1 times 4x minus 1. So both of these are factors now, divided by x plus 1, x approaching -1. This cancels, so this become limit of 4x minus 1, x approaching -1. Because this common factor is canceled, so we have 4 times -1 is -4, -5 is the derivative. So -5 is the slope of the tangent line. We'll write the value of the limit is -5. That's right. All right, there's one last thing. That is calculating the equation of the tangent line. This we've been practicing. The equation of the tangent line is supposed to be practicing this. Now, equation of the tangent line have a format that is y equal to f prime c multiplied by x minus c plus f of c. Now, we already know the point is -1, 6. Now, we have it already here as well. This is -1, that is 6. The new is 6. But since the question itself is giving us, it's giving us -1, 6. And that's really the value for c. That's the value for f of c. It's the x value and y value for the tangent point. So this is the -1, and this is the 6. And now we also know f prime of c is f prime of -1, and we calculate it as -5. It's -5 there. And we have the slope right there. We have this either 5, -5 times x plus 1. And then plus FC. That's pretty much the tangent line. Or any question? Other than the definition part, this part is maybe new. But the answer is really something we were doing in section. The answer would be -5 times 6. All right, you can also confirm this by graphing your graph the tangent line. That is anytime whenever you're determining the tangent line, you can compare with the original function to see plus 2x, and the tangent line we have is like -5x plus 1 plus 6. 3 is so that's the point of tangency versus tangent line that we determine. That is a problem. I hope it helped. Any questions? So this one does have a slight change to the definition. It says that the f prime of -1 is the limit as x approaching -1 of the expression that's x minus -1. This is f of x minus f of -1. The definition actually makes more sense to me because it's really showing the subtraction of y value, subtraction of x value here. And as approach from this point, approach this point, these 2 points are joined together, give a sense of the tangent line. The only problem is this limit cannot be called f prime of x because the notation would be complicating. We have to make it this way or make it that way. That's how it's slight problem as far as a variable name, which is why we normally prefer this. Any other question for the homework? Yes. Okay, suppose f is given. We use this table, estimate f prime of 2. So we would find the derivative at 2 using the value in the table. The f prime of 2 is a slope at 2. So if you are using the slope value, you can estimate it. So I guess we can use the 2.0 and 4 as like we just find a slope value. Slope is subtract the y value divided by subtraction of the x value. So one of the ways to do this. All right. Another way is you can try to visualize what's going on. And kind of see what the solutions is where 0, -2. 0, -10, 2, -12, and then 4, -15. All right, so you can see the point seems to be going that way, right? You try to graph them. So if you want to find the slope at that point, if you connect the point, you get the tendency of the graph, right? Right, the graph, the point given ID. So I feel like if you want to find the slope or tangent line here, you can connect each point in that point. Right? So that's the idea. I think, well, there's more point if you're going to keep graphing it, you can kind of see the tendency. But now we can't see, we can use this 2 points. The point 0, -10 is the point before 2, and the point 4, -14. That is the point after the 2. We try to estimate approximately. Because the derivative is slope the tangent line, so we don't find slope of the tangent line at that point. So this is calculation slope is equal to subtract the y value that goes negative 14 minus negative 10. Subtract the y value, so we're 4 minus 0. Okay, that ends up being negative t plus 10, negative 4. So this is negative 4 divided by. So it's roughly negative 1. And I think you can also see it by the graphing. That looks like negative 1, right? We go 1 down, 1 up, 1 down, 1 up. It looks like the slope is going down, but one step, 1 unit at a time. So they will be negative 1. And kind of confirm our estimation. First one. Right. Now B, for what value of x the derivative seems to be positive. And we can see in the first few points, they looks like negative. It's going down, right? I guess to understand the overall tendency, you have to graph the rest of the points. 6, negative 17. Negative 17. We can graph it by hand as well, but with a computer, it's more exact. And we don't have to graph it with this graphing. If we do it by hand, it's not that hard, but with computers, really easy. Now, 10, negative 17. Start going up now. 12, negative 18. Right, so you can see the function is going down, going down, going down, and start going back up, right? I think the only point that's definitely positive is this point. The green one, you can go here, the green one was 10, negative 17. So it's, so back to the question for what value of x, I'll say 10. 10, the derivative, still that point, the same to be positive. So it's negative, 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 negative. This looks like a 0 because it's turning. And that's positive, and then positive maybe. But 10 definitely is positive, so let's submit. This is an interval. So we're supposed to enter interval. Interval. This is 8, this is 10, this is 12. So I'm guessing 8 to 12 seems to be increasing, and 0 to 8 seems to be decreasing. So it's decreasing all the way and then increasing from 8 to 12. So enter interval. This is an interval. 8. That looks like it's fine. Last question for what value it appeared to be negative. So we were, if your answer as the interval, okay, I was a little complaining in my head that where did they say we should enter interval? Okay, so let's enter the interval. It looks like, I think it's since 0, and then this is all the way decreasing into 8. So I would enter 0 to 8. That is negative, so 0 to 8 is decreasing, 8 to 12 is increasing. And that's question 6. So we're using the point to understand the tendency. Any other questions? Let's start a little on the second section of page 2. Basically, section 1 was the definition of the I guess it's really repeating what we're talking about. Since we define the derivative, we want to be able to understand the meaning of the derivative. That's why the title side interpretation of the derivative. Okay, number one, if you can understand the derivative as instantaneous rate of change, because the function is a relation between two quantities. So x equal f of x or y equal f of x is relating these two quantities x and y. One is considered the input value and the other one is considered the output value. Now the derivative give us the relation between their changes. So sometimes I might skip the word instantaneous, just call it rate of change. So if you have y equal to f of x, all right, and then we call the y prime equal to f prime of x. This is the notation for the derivative function, which is defined as a base limit calculation. Just really depend on the original function that is how we calculate the derivative. So some notation, especially in Europe, we call this dy dx. So then really the numerator is the instantaneous rate of the y, or change of the y value. Denominator is instantaneous change of the x value. See, numerator is how the y value is subtracting, so that gives us change of the y value. Denominator is the x value minus the second x value. The denominator is change of the x value, and we're making the change of the x value to go to 0. So the denominator is super small change of the x value, and numerator is this change of the small change of the x value causes a really small change of the y value. Theoretically speaking, when the denominator approaches 0, the numerator also approaches 0, but this ratio is not approaching 0. This ratio is approaching a specific relation between the changes, right? So we are calling it rate of change. The word rate is the same initial three letter as the word ratio. So how do we calculate ratio? We divide them. And so you are using the change of the y value divided by the change of the x value. And because this change is a small change, which is why we use the lowercase e. All right. So number one thing, the derivative allows us to find rate of change. Right? How is the relation between their changes? Is it changing fast or is it changing positive? It's really important to understand that. And also many word problem, and especially in physics, where we're considering how is the rate of change of this quantity as the other quantity is increasing. So we often look at the rate of change, or the rate of increasing, or the rate of expansion, the rate of something. Whenever you read the word rate of something, you think derivative, think slow. And this is one of the interpretation of derivative. Okay, let's look at a question. This is about word population. We can actually find the word population every second. Okay, so this is real-time data for word population. You can see every second somewhere in the world. Know that this is a real thing. This is actually real-time data in 2012 when the book was written. So at that moment, on that day, the population is how do you pronounce it? Well, billion. So it's really a super large. So I don't want to pronounce every single number in there. So really a large population here. Now, what is P prime here? That is the derivative of the population function if the population is a function. But really, we do not have We do not have a function that model the population. Many real world data, they do not follow a formula. There's no function that actually model it. They're real-time data. And the way we consider the derivative of that function is actually a rate of change. So you find out the change of time and you find out the change of population. You use those two pair data and find the slope. That's how we find it. So basically it's about 156 people per minute. Actually, you can even calculate how many people per second. When I was looking at the website, it would say 2 people per second born every second. All right, so you can try to, so this is one of the data, so where this is really the instantaneous rate of change. Okay, another example is from manufacturing. And so we have this information says if you manufacture 1,000 products, he represent the profit. So the profit is 500. Let's assume it's $500. So the derivative is 0.25, meaning that if you manufacture one more of the product, you get 25 cents more as your profit. So then we can use it to approximate what if you manufacture 1,100 products, what's the profit? Understandably, ideally, if you make more product, you should have a higher profit. But you want to, as you manufacture more product involve costs. So we want to see if the actual profit worth the cost of it. But let's try to estimate the profit first. So if it's 25 cents per product, this is 100 more product, right? So you would take the 25 cents multiplied by that 100 extra. This is subtraction. 1,100 minus 1,000 is 100. That is the differences. That's a change of the x value. And then we multiply that with 100 multiplied by 0.25 give us 25. So we get 25 extra dollar. So the total profit will be 500 originally plus the 25 plus the $25 extra. So that gives an estimation of a possible product if we are making 100 more products to get a higher profit. So the higher profit is there. So another benefit of using the derivative is it gives you an approximation of what's going on if there's more product. And the first example is according to this estimation, at this moment, every minute there are 156 people born, which means 1 minute later, the population is going to be this number plus 156. So the derivative as a rate of change allows us to calculate what's going on moving forward here. So one of the benefits of knowing rate of change is being able to predict. All right. As you can see with this example, one of the things we can do is to approximate or estimate or predict. So the formula is really similar to what you would do in the calculation of the tangent line. And I'm going to write it on the board. So the less formula we memorize, the better. And the approximation function really is the same as the tangent line equation. So our tangent line equation goes y equal to f prime of c x minus c plus f of c. So which is similar to here. This h is a change. Remember what's the h? H is subtraction of the x value. If you subtract the new x value with the old value, that's where the h goes. It's really the same thing as the h. So f prime times the h or f prime times x minus c plus say f of c. That is our estimation. Basically, f of c is the original y value. Now, how much it changes, this part, we're using the derivative multiplied by the change of the x value as the estimation of the change. So originally, the y value was here. now y value is here. This is approximate how much change is going to happen. That's why this one is called rate of change. If you want to find out how much change is going on, you use your rate of change multiplied by the actual change of the independent variable that allows you to calculate the change. The change plus the old value give you the new value, which is the estimated value. We're calling it FC plus H here. But these two, consider using the tangent line as a way to memorize this formula. Another way to think about this is the new y value for the old value plus the change. And change can be estimated using the rate of change multiplied by the change of the x value. So below here, we have a little exercise. Suppose that the original value at 25, when x equal to 25, the z value is 187, and the derivative of 17, meaning that the rate of change at 25 is 17 per x value. So we want to estimate what is the 20, and this can be calculated using the formula that you see in the board. Or you can also think of it using the formula over there. So really, we're trying to figure out what is the 20. All right, this is actually going forward. Instead of plus something, we actually have to subtract. So compare what we're trying to do. We knew that D20 is not too far from D25. So we know that D20 is 187 plus the change. You can think of it this, all right? So then this is equal to the D25 plus, let's try to compare these two. New y value or new v value, new alpha value. This is the old alpha value, and this is a change. The change is calculated by the rate of change multiplied by the change of independent variable. This is going to be multiplied by the time of 25, multiplied by the change. We call it h, but how do you calculate h? H is change. H is a value that can be calculated using subtraction of the two x value. So let's actually do the calculation. The Z25 is at 187. The derivative is 17. And 17 should be multiplied by the h. So how do we calculate h? Is the new one multiplied by the old one. The new one is the 20 and old one is. And that's all there is to the calculation. It looks very much like the point slope formula for the tangent line. The derivative multiplied by x value minus the x0 plus the y0. That's really how we calculate it. I hope that gives us some indication how to do the homework. It's very much a calculation on the final answer is 102. It's kind of like applying the tangent line for the work. And we'll do more practice questions tomorrow. And hopefully tomorrow I'll finish reading the test. And I'll see you tomorrow.
Yes. No.
I do.
Okay.